All right, everybody, welcome to the next edition of Queued Up Mobility. I'm Trevor Paul, Chief Mobility Officer for the state of Michigan, and welcome to our virtual kitchen island, where today we'll be exploring the future of LiDAR and radar. But let's start with the basics. What exactly does radar do? How does it help a car drive itself? Well, radar uses radio waves to detect objects and determine their range. How far away these things are, the angle at which they are, how fast they're traveling, the velocity. I mean, really important stuff. Now, what about LiDAR? What does it do? Well, LiDAR does basically the same thing, but with pulsed laser lights. Think of a nightclub with invisible different strobe lights that go out into the environment and read back to a car how far things are and how safe that car is in traveling in the same direction. Because light travels at a constant speed, the round trip time can be translated into a precise distance estimate. That's why LiDAR is so cool. And the result is like this 360-degree 3D model of the environment around the vehicle, which helps it understand its surroundings and make real-time decisions. LiDAR systems have the ability to identify objects, vehicle types, cyclists, children, animals, and track their movements and direction. Both LiDAR and radar are both considered foundational technologies that are necessary to achieve autonomy and scale. But of late, with their popularity, cost and performance barriers have hindered the development of it, just like any other new or emerging technology that the world has ever seen. Sure, LiDAR wins on accuracy, and we know that it's critical for AV safety. And radar wins on range, reliability, and price. However, we all win if they are combined. These two sensor systems are complementary and fundamental components to the autonomous stack. So where do we go from here? What does the future hold? Time to pour a stiff drink. I know it's a little early for those at Eastern Standard Time, but let's get after it. So we are fortunate to be joined by leaders from two pioneers in the industry, Velodyne and Metawave. Velodyne is considered the LiDAR leader with 70% market share, widely called the main supplier of the eyes of the autonomous revolution. How cool of a reputation is that? It's a position which is soon to be worth billions over the next few years. And now let's talk about Metawave, the radar industry disruptor. Metawave is focused on radar and 5G connectivity, both of which are key components in future CAV deployments. It's a core product. And their core product is a low-cost radar that is blended into this really sharp AI software platform that can be modified to fit any automotive sensor suite. The platform focuses on enabling highly automated driving and advanced automated safety features. Think like lane assist, adaptive cruise control, highway pilot, all the things that are going to shape the future. These companies are shaping the future. And here are the executives within those companies that are shaping the future. I'm thrilled to introduce Maha Achour, CEO and CTO of Metawave Corporation, and Nikhil, VP of Software Engineering at Velodyne Lidar. These are the exact right people to be joining us today. Thank you for joining us. We're thrilled to have you. But before we dive into our conversation, I'd like to remind viewers that we'll be taking your questions today. This is going to be an interactive Kitchen Island conversation, virtual Kitchen Island conversation. To get your question to our panel, simply go to slido.com, that's SLIDO.com, and enter our event code, hashtag NIAS, hashtag NAIAS. Type a question and submit, and we'll get to as many questions as we can. But now let's get talking. Maha, if it's okay, I'd love to start with you and learn a little bit more about your company and your role. So maybe I'll turn it over to you. I think you have a few slides to share.
Thank you, Trevor. Thank you for the opportunity to share with your audience about radar. As you know, the industry is quite familiar with cameras and LiDAR, which are all optical sensors, and the radar has been only considered for cruise control. So what Metawave has been focusing on since we started in 2017 is the 5D imaging radar. And let me explain to you why this is critical. As you can see in the sensor fusion on the right, all sensors are needed, like Trevor mentioned, especially to overcome some of the obstacles that can create some hazardous condition for these self-driving cars or L2 plus vehicles. But as the radar becomes more and more enhanced in performance, especially using Metawave technology that combines the analog front end with the digital back end, and on top of it adds the object classification at the edge, it is able to detect clearly and precisely object beyond 300 meters. This is very easily. This is something we're doing today. Pedestrian beyond 250 meters. This is something that we're doing today. And also, as you mentioned, resolution is something that as the camera and LiDAR are very known for because of the optical wavelength, something we cannot compete with, but we can get close to that. And at these long ranges, maybe you do not need a 0.1 degree angular resolution, but maybe a 1 degree is enough. Today, we demonstrated 1.2 degree at these long ranges, and an accuracy we're going towards 0.2. So you can really separate these objects as you're driving the car full speed in a bad weather condition on a freeway. And then the other point, of course, is how fast the sensor fusion can get this information and how this information can impact the rest of the sensors to optimize, you mentioned it, the cost, the delay, and most importantly, power consumption. Because most of these cars are EV cars, including the Teslas of the world, and every single watt counts. So the addition of the AWARE, which is the brain behind the radar, enable these kind of capabilities. So if we go to the next slide, I'll explain to you what AWARE is and how Metawave is the first company to demonstrate. Next slide, please. So our AWARE platform is based on a sensor fusion that we built internally, ground up. It's a variation of convolutional neural network where we blend data collected from a Blackmore LiDAR. The reason why we use Blackmore LiDAR is because it's an FMCW that, as you can see from the picture here on the red dots, it goes beyond 300 meters. So we can clearly train the radar with these very powerful LiDAR sensor. We also have a very high power cameras. We collect the data and then offline, we take probably 2%, 3% samples to validate the labeling. And we are today at 90% accuracy, which is unheard of in a radar. That means our radar today, when it drives on the freeway, provides the range, the velocity, the angle of arrival, also provides you the label. It can discriminate between a motorcycle from a car, pedestrian from a bicycle, and so on. So we're very excited to be pioneering that. I truly believe once the radar gets more and more advanced in the next few years, it will play a major role in the ADAS suite. If we go to the next slide, I'll explain to you why. Because as you go to mobility as a service or robotaxis, obviously you do not want to shut down the service if you have bad weather conditions. So this snapshot on the right, as you saw previously, the Blackmore LiDAR was able to see beyond 300 meters. This was a snapshot of a detection with our radar in the month of September, where there was ash in the atmosphere in the Bay Area with some haze, combined with some haze. You can clearly see the range of the LiDAR has shrunk from 300 plus to 125 meters. And then the radar still operates at 275 meters. So in terms of the range, in terms of the weather, in terms of the bugs, in terms of the sand and all of these extremely challenging driving conditions, the radar is always going to be the main sensor that alerts the sensor fusion way ahead of time of any hazardous condition. And this is just the beginning, and we're very excited to be pioneering this. Thank you.
Awesome. Thank you for that overview. And for those students from Wharton that are listening, I hear that this particular panel you might get tested on, because Maha is instructing a class from what I gather, and this is required reading or required watching. So continue to take notes. I hope this is going to be good for you. So now I want to turn it over to Nikhil. If you wanted to spend a couple minutes just kind of walking us through your role in your company, that'd be awesome.
Thank you, Trevor. Good afternoon, everyone. It's really good to be here. My name is Nikhil. I am the VP of Software Engineering at Velodyne Lidar. And when we talk about software engineering, you think about a LiDAR company as a hardware company. But what we are doing is not just building our LiDAR, but building solutions that enable our LiDARs to be easily integrated or adopted in a number of different industries, starting with automotive and autonomous driving industries, of course. So if you can go to the next slide. If you could switch to the next slide, please. So just a little history of Velodyne Lidar and our beginnings. Velodyne as a company has existed since 1983 in a completely different vertical, which was in acoustics. In 2004, the founder of Velodyne, who is an innovator and inventor, participated in the DARPA Grand Challenge, which many of you would know was sort of the birth of a lot of autonomous driving efforts that we see today. The key takeaways from that led him to invent the very first real-time surround view LiDAR in 2005. We commercialized the product in 2007, and for the past 13 years, we have been improving the product, scaling up manufacturing, scaling up our customer base. And where we are today, as Trevor has said, is we are the leader when it comes to LiDAR for automotive and other applications as well. Go to the next slide. So we have a range of products. I want to talk first about our rotational products, which you see here on the slide. The Alpha Prime is one of the industry's best-in-class LiDARs for long range and for autonomous applications and a number of non-autonomous applications as well. It's a surround view LiDAR, and it is based on the original thesis where a real-time surround view LiDAR would be most applicable for autonomous driving. As you scale down the size of the LiDAR, we have a portfolio of products, including the Ultra Puck and the Puck. And these are smaller sensors, but very capable for both autonomous driving as well as robotics applications. And then finally, the Velodyne Lidar is our directional LiDAR. We recently announced the latest solid-state LiDAR, which is the Velodyne H800. And we have basically taken our learnings from 13 years of development on LiDAR technology for automotive and ADAS and autonomy applications and brought it down to an ADAS-capable sensor. When I say ADAS-capable, the Velodyne is the sensor that we see as really revolutionizing the driver assistance market. And it incorporates all the learnings, all the capabilities that we have built up over the past several years of research, development, and manufacturing. And it has culminated in this sensor, which has a phenomenal capability for enabling the next generation of driver assistance. So if you could go to the next slide. Just in terms of the different markets and industries where LiDAR is applicable, of course, the number one use case that was the motivating use case for the inception of a company itself was autonomous driving. But beyond autonomous driving, we have multiple verticals. Mobility for both delivery vehicles, things like contactless delivery, automated ground vehicles in robotics applications like warehouses and factories, applications that involve infrastructure maintenance and monitoring using drones, sensors for mapping, sensors for smart intersections, and of course, driver assist as well. The driver assistance features that we are developing is the best in class. We are not just building the hardware, but the software, which when coupled with our LiDARs, enables cars to perceive the world, not just capture the raw signal, but then convert those raw signals into symbols that are usable by vehicles to discern objects in the world, to understand where they are in the world, and how to react with the rest of the environment. You can go to the next one. That was my last slide, but I'm really excited to be here and talk about what our LiDAR can enable and contrast that with what exists today as well. So thank you for having me, Trevor, and excited to be here with you and Maha.
That's awesome. So I first met Nikhil when he was with a startup a few years back, and it's been awesome to see his trajectory, and now he's doing some amazing things at Velodyne. So are you guys ready to get queued up? Because I'm ready to get queued up. So the first question I have for both of you, and feel free to chime in, whoever would like this. Some in the industry would say that we are in the midst of sensor wars. Is it LiDAR versus radar, or how will the two coexist in autonomous vehicles of the future? And I guess for Nikhil, is there one LiDAR that's going to rule them all, or will autonomous vehicles use a variety of different types? And same with the radar question. Give me your thoughts on the future, guys. Is it LiDAR versus radar?
Maha, do you want to go first? I think you might be muted, Maha.
I'm sorry. Yes. As I said, that today all sensors are required because, especially when the driver is out of the loop, human lives are priceless. So definitely there is a need for LiDAR and radar, maybe multiple radar around the car as well. So we see more and more, increased number of radar for the corner, and especially for right turn and left turns and so forth. But fast forward 10 years, 10 years from now or 15 years from now, as the sensor fusion becomes smarter, as these sensors become more powerful, we will see some transition and some consolidation among the sensors. But for sure, the radar is always going to be or become the primary sensor because of its operation at these long ranges and also during these harsh weather conditions.
I just want to add to that. I think Maha is absolutely right. Sensor fusion is going to be the name of the game. And it's not a LiDAR versus radar. The way that we think about it is if you just think of each sensor as one circle in a Venn diagram, where you have a LiDAR, you have a radar, and you have cameras, there is a pretty strong intersection. And then there are the individual capabilities of each sensor. That intersection is something that has to be focused on. So, for example, if a radar fails at detecting a pedestrian 1 in 1,000 times, a LiDAR fails 1 in 1,000 times, a camera fails 1 in 1,000 times. Now, when you combine all three sensors and the three sensing modalities, which are complementary and orthogonal to each other, the failure rate is 1 in a billion. And when you have that kind of capability, that's what becomes an enabler for the on-ramp to more and more autonomous driving that is both worry-free mobility for the world, but at the same time, it is safety related for not just the passengers and the driver, but also the pedestrians and other vulnerable road users around the vehicle as well. So it's the combination that really enables that. And over time, it's just a question of how these different sensors can get fused. Are they going to happen early on in the data production stage, or are they going to happen later on once they've been converted to symbolic level?
Now, you both alluded to emerging technologies, and I have a question. Are there emerging technologies that could further tip the commercial scalability of, for instance, LiDAR, i.e., harnessing silicon chips to make LiDAR simpler, or smaller, or less expensive? Are there emerging technologies that could drive step change advancement of radar capabilities? What are your thoughts on that?
So on the LiDAR side, I can say that we are already moving towards more and more manufacturability. It really comes to scalability, manufacturability, and affordability for making LiDAR adoptable broadly. And we recently announced our solid-state LiDAR, the Velodyne H800, which incorporates what we call the MLA chips. These are essentially LiDAR architecture, micro LiDAR architecture-based chips that incorporate a number of transmitters and receivers in the size of a postage stamp. It's not just improved quality as a result of that, but it's also automated manufacturability and low cost. Right? This is what enables the entire sensor to come down to a target price of $500. So that's where we're headed. And that's what's needed in order to bring LiDAR to the level of scale that is currently necessary for the automotive industry.
Yeah. And I would add, Maha, for your answer, I know that there's power in long-range 5D imaging radar. Its role in highly automated driving, from consumer vehicles to robo taxis to AV trucks. So in your side of this answer, if you want to touch on that, would love to hear more on that.
Yeah, sure. So on the radar side, as you know, that in the value chain, you have the tier 2 that builds the transceiver chip. So I know Nikhil mentioned that they had to build their own components. And the radar, there are so many different components available. But the problem is that they do not meet the target goals in terms of performance, size, power consumption, and cost. So as you get to the next level of L2 plus and beyond operation, regardless if it's a consumer market, robotaxi, AV trucks, trains, and so forth, you need to learn from the telecom industry. And we come from the telecom industry where the system has been optimized not only by optimizing the digital signal processing. So most of the radars today, they optimize the signal, the zeros and ones, Moore's law. What Metawave has done, it brought back the analog, Maxwell's equations, exactly how the telecom industry did, to basically balance the complexity to get to these performance and price points and cost. And as we further improve these front ends, so we're not at tier 2, we're not at tier 1, we're between the two to enable this kind of performance. That's why, as a pioneer in that space, being the first one to demonstrate all these capabilities, we filed over 200 patents, with the first 6 being allowed, to make sure that as we keep our leadership in that market, we also create barriers.
No, that's awesome. That's a good answer. So I'm going to pull it back out and ask a sort of a general question, but an important question, I think. What are the biggest remaining challenges being faced by both LiDAR and radar companies today? I mean, you think about emerging technologies trying to make their way into a very, very established value chain. It can be tough. So what are some of the challenges in doing that?
I can go first. So, we've been in business for 3 years, not as long as Velodyne. So, this one, Nikhil has more experience. But from our opinion, is basically educating our customers, regardless if it's a tier 1 or it's an OEM, about all these various capabilities. I think you cannot break the law of physics. You cannot bring a smallest radar and still get the 1-degree resolution. So it has to be, a full understanding of what can be achieved with the constraints. That's kind of the main challenge that we're facing, is educating our customers with what eventually this next generation of radar can be achieved without breaking the law of physics.
For us, I think of this as the technology is improving. We have increased our ability to manufacture. We have manufacturing partners around the world. But one of the things that really is going to be necessary for both the radar and us company, as well as Velodyne, is policymakers adopting more stringent requirements for the safety of the public, safety of vulnerable road users. And that's naturally going to drive these kinds of technologies into vehicles. So more public mandates for things of this nature, just like backup cameras, are now becoming ubiquitous on 100% of vehicles. Now, when you think of where LiDAR could be most useful, LiDAR is, of course, it enables vehicles to, car companies to offer convenience features. People love to pay for convenience features. People love to pay for a system that keeps the vehicle within the lane, beeps if there's going to be an oncoming vehicle in its blind spot. What people generally don't tend to pay for is safety. And this is where government mandates and government involvement in the form of new rules for NCAP, which is the new car assessment protocols, will help with the adoption of more LiDAR and modern radar technology for improved safety of pedestrians, for example. That was on Maha's first slide. She said that they are capable of seeing pedestrians up to 250 meters away, which is phenomenal. But the thing that I feel is going to be necessary on the other side is for the government to really step up and start making these kinds of technologies more and more required for the automotive industry to start adopting.
No, that's good. Now, I know, Nikhil, you mentioned something about about a puck sensor. Can you? There's a question coming in from the audience. I'm trying to get to as many as I can. Everyone out there, so thank you for sending them in. Can you just explain sort of the everyday application of that? Like where do these fit on an auto? If you could just really concisely, in layman's terms, walk us through how that would work.
So the puck sensor, for those who aren't familiar, is one of our rotational products, and it comes in two varieties. One is 16 channels, and the other is 32 channels. It's a small, lightweight sensor that has been tested in the field for years, draws very little power, does not overheat, and it has been ruggedized to work in a number of industrial applications as well as on-road applications. Now, this kind of sensor is already being adopted in a number of different use cases. For example, we have some customers of ours who integrate the puck within drones to fly them into construction sites, over construction sites, and other areas in order to build dense three-dimensional reconstructions for understanding and what's in the scene. We have customers that utilize these sensors for mapping applications. And now as a result of COVID, there has been a phenomenal transition in people's thoughts around contactless delivery, contactless factory and factory automation. And there are a number of applications in that area as well where the puck sensor is very usable. So if you sort of skate to where the puck is going, no pun intended, these types of sensors, be it the rotational products or the directional products, as you scale them down and make them ruggedized for industrial deployment, you can just think of a number of autonomous and industrial applications where these would be useful.
Yeah, that's good stuff. So this next question, I want to start with Maha on collaboration. So what's your thesis on collaboration at this stage in the race? Do you think companies could or should collaborate instead of trying to compete with one another, developing sort of these, in some ways, overlapping technology? I mean, could you see at some point LiDAR getting integrated into radar 5 years from now? What's your view on where we're at in this race, and what's the best way to collaborate going forward?
That's an excellent question, because at the end, the goal is to minimize power consumption in getting to how to control the car, right? And getting the right decision. So the higher consolidation you have at the edge, not only from a hardware perspective, but also from a software perspective, you can create what is called regions of interest. So this way, if the radar can see on a freeway a motorcycle driving side by side with a car, it alerts the sensor fusion if there is a LiDAR or a camera at the edge. We have these kind of at the edge processing, multiple edge processors with these hybrid sensors. You can further improve the power consumption, the delay, as well as the cost. But that will take time. Things don't happen overnight because every company is trying to optimize its own sensor, but consolidation has to happen. And maybe we'll see more radar plus cameras first because of the cost before we see radar plus LiDAR.
Yeah, that's a great answer. Nikhil, do you want to weigh in?
I do. I think Maha is absolutely right on the edge side. But there is one place where I think collaboration is going to be more and more necessary is on the data sharing side between companies. So that, if we're dealing with public safety, what we want to do is share as much data as possible on edge cases and outlier scenarios that some sensors can capture, that have captured, in order to educate the rest of the market and get everyone to build towards this future vision of safety, what some people are calling vision zero, where they want to have zero accidents in the future. And so it has already started a little bit in the autonomous driving sector. We see autonomous vehicle companies opening up their data sets and being more amenable to sharing when they've had accidents, what the frequency of accidents are, etc., which they call disengagement rates. But in general, this kind of data sharing, I believe, would be an excellent place to begin collaboration to move the industry forward in a positive manner.
That's great. So I want to turn a bit into the competitive landscape. I'm trying to combine multiple questions from multiple audience members. So forgive me, everyone out there, if I didn't get it word for word. I'm trying to get the good content I think everyone is looking for here. So, there's critics out there. Some people like Elon Musk have expressed skepticism about LiDAR as the critical technology. And so I think the first half of this question is sort of, what do you say to the skeptics? But then if you look at sort of what the OEMs and the tier ones are doing right now, like for instance, Volvo recently announced that it will have LiDAR-equipped AVs rolling off the production line in 2022. There's all these skeptics, and even at the OEM level, like Tesla, there's also OEMs that are playing in this category very, very actively. So if you both could sort of address the competitive landscape, both from an OEM tier one level, and also address all this activity that we're potentially going to see with OEMs playing in the category.
I can start by talking about that because you're right that companies like Tesla with Elon Musk have been publicly saying that they don't need LiDAR. But the way we see it is OEMs are, as you said, car companies are already taking this very seriously outside of Tesla, which I cannot comment on. But anyone who takes safety seriously is considering all sensors. Again, going back to my earlier analogy of the intersection of the Venn diagrams, you really want at that intersection a highly capable, robust, complementary sensor in order to enable more and more autonomy. We talk about the different levels of autonomy, which has been really nicely articulated as legs-free, which was adaptive cruise control, followed by hands-free with lane keep assist. And now we're moving towards eyes-free and potentially mind-free. If we do indeed want to move in that direction and having safe autonomy and autonomous driver assist capabilities that is going to be broadly adopted, it is going to be necessary to look at all the options and choose a compendium of options that are complementary rather than having sort of a maniacal belief in one.
Yeah. Maha. So, I mean, I know that, the way that I framed the question was very much towards LiDAR, but radar, I mean, it's also a very competitive landscape. And there are, like we alluded to earlier, all these emerging technologies that are going to drive the step change advancement. So how do you view the competitive landscape for radar, both from sort of a customer level, but also at the level you're playing at? And how do all these emerging technologies come together?
Yeah, so here I can classify radar solution, what I call the conventional way, which is everybody else, and the right way, which is what Metawave is doing. And everybody knows today, maybe you have only one sensor at the front, interference is not an issue. But now in the future, when every car has 7 sensors or blasting around the car, interference would be an issue. So we factored that in also early on. It's not easy. We had to build our own beamforming ICs. We had to build our own, algorithm that operates with that to reach this kind of capability. And that's just the starting point. So on your question regarding Elon Musk and the Tesla, I think I would like to classify it into 2 categories: vertically integrated companies versus traditional OEMs. So vertically integrated companies, of course, they're building their sensors too. Tesla is building its own camera, right? And I don't would be surprised if they build their own radars too. And the way how, in my opinion, Elon Musk interprets that is that if he creates a brain that works only with radar and cameras, 10 years from now, I'm not talking about today, 10 years from now, it can need level 4, especially when you have the V2V and V2X ecosystem around the car. So it's just a matter of time. But today, I agree, with Nikhil, all sensors are required.
Yeah. So, Maha, I have another question for you, and I'm curious myself. It's coming from the audience. What is a metastructure? How does that work? If you could quickly explain precisely, but if you can.
Yeah, so I've been doing metamaterials since 2004, right? And you just go and Google the patents and you see how many patents I have in that. And we emerged from Xerox PARC, licensing their active metamaterial to scale it to radar. Unfortunately, it did not work. So we had to develop our own technology, but we're not using metamaterial or metastructure. for the radar. We're using our own IP. But today, we announced a great partnership on the 5G side. We're using Metastructure. So these are kind of man-made structures that have unique electromagnetic performance that you cannot achieve with conventional designs.
Okay, got it. That's what I thought it was. Trust me.
Yeah.
So we got about 3 minutes left, which gives us time for one more question and 2 good answers. And I want to frame this as say whatever you want, even if it's not right in front of us. What does the future hold? And that question is around edge cases. What is an edge use case for LiDAR and radar that excites you both? And maybe it's something with the role of AI. It could be anything, but talk to us about the future and these edge cases for LiDAR and radar.
I think I'll start with talking about there's applications, and then there's technology where we deal with edge cases. So on the technology side, there are a number of things that we're now starting to see in the real world where you're needing to not just recognize pedestrians, but recognize pedestrians on all types of new mobility platforms, on scooters, and it's not just a bicycle anymore. People are now sort of moving from just being on their feet or being on bicycles to different types of mobility platforms. And this is where LiDAR is extremely capable, and that's some of the scenarios that we are quite excited about at LiDAR, being able to leverage AI and software to not only recognize that it's a person, but also recognize at what speed are they moving, what kind of mobility platform could they be on? Is it a bicycle? Is it a scooter? And thereby predict where they're going. So if you're able to solve the prediction problem, which is something that's very interesting, then you can actually reduce collisions, because you can predict that there's a collision that's going to happen within a few seconds or some time frame. And those are the kinds of technologies and edge cases that we're quite excited about enabling for urban mobility.
Very cool.
Yeah, I think for the radar is security, definitely. I think the highest priority for an edge sensor is security. In case there is a breach of security in the sensor fusion or in the car, the role of these edge radar, especially analog radar, which are only the LiDAR and radar, they should really alert that you should stop. You don't really want to go into a stampede in a crowd if there is a car. So security, in my opinion, is going to be one of the top role of an edge sensor in a closed loop environment.
Awesome. All right, Nikhil, close this out. This is a bonus question. So I want you to fill in the end of this sentence with one word. The future of LiDAR is blank.
Ubiquitous is what I would like to say is the answer to that question. I genuinely believe that we're going to see LiDARs on as many devices as you think of from like a consumer application. There'll be more LiDARs than there are iPhones. So that's my belief.
Okay. And then Maha, the future of radar is blank.
Exciting.
Okay. All right. I think that's a good place to end our conversation. I've really enjoyed it, and I've learned a lot. And I hope you all did too, out in virtual automotive world, mobility world. And I'd just like to invite you to visit nias.com. There are going to be future conversations like this. The Queued Up Mobility series continues to roll on. So again, visit nias.com, NAIAS.com. Thank you so much to our panelists, Nikhil, Maha. It's been awesome, and I hope we can talk again soon. So thank you, and thank you, everybody.
Thank you, Trevor. Thank you, Maha.
Bye-bye.
Bye.